That's what I like to see, is where they're doing the most of this.
Yes. So with that system, you get the interaction between them. I love that because you get the oscillation.
Oh, I see how you did the timer down here.
Yep, that was tricky to get. That had to shield it from the stator and these rollers. Otherwise, it threw it off. You would get no reading. But I put that shield, and it works. I mean, it's simplistic to look at, but it was hard to come up with.
Oh, I bet.
Just the right angle and. Oh, this is your idea. I bet you're going to print this with waves. Full ceramic model, but I haven't done the waves on it yet. But yeah, I have all enough magnets for the rollers. I'm going to machine this so it's perfectly smooth on the ends.
You got the different inners.
Mm-hmm. This is going to be for this model.
Gotcha.
This will be for this model.
Dude, this thing is stinking solid, man.
That was hard. 5 years ago, easy to find these rings.
Can't find them now.
One company in China. That's it. So I bought 3 of them. Because like once they're gone, they are gone for me.
And this is all 3 stacked together.
3 stacked together. They're hard to find now. Yeah, 10 years ago it was easy peasy. They were all in the United States. You could buy them, but nowadays.
And what strength are they?
They're grade 8 ceramic. So they're decent. It's not crazy. Not like neodymiums.
Oh no, I feel that though. That's strong enough.
Yeah, definitely strong enough. Fernando's first model was this, and he just painted the layers on it. That's all he did. Yeah, because on some of the pictures you can see there's 3 layers he put, and that's how he did it. And he just had ceramic, and he put copper jackets or aluminum jackets on, and that was it.
Oh man, that's what, I don't remember giving you this idea, but I'll take credit.
That was totally you. We had a conversation. You're like, you ought to just go magnets to magnets, and so I went.
Oh, okay, yeah, because
jackets and everything.
Yep, when you got all these extra jackets and everything in there, you got all these eddy currents. You're not getting eddy currents if you're doing this.
Exactly.
Yeah.
And Searl's very, very first one was homogeneous. It was just the elements blended together to make one. No layers. Like, you know what? I'm just going to do it. Magnets to magnets.
Yeah, I'd be really interested to see how this one plays along.
The field lines are going to be, so like the field lines, just for instance, the field lines on the stator will be this direction. The field lines on the roller are that direction. They're all intersecting different angles.
And compared to this, even though the copper is non-magnetic, when you got these things running, you got those eddy currents are fighting with the other magnets, right? And so now the magnetic fields, instead of being nice and clean, are getting all complex and crazy, and keep it simple. Keep it simple,
yep, and that'll be I'll probably drive it with the same kind of thing here, or maybe the outside pulsars, but speaking of this, you might like to see this.
Oh yes!
So this is just a normal magnet. It won't spin until you put an oscillation in.
Yeah.
So as long as it gets an oscillation, it grabs it and spins it.
There's no magnets anywhere in this.
No magnets in this. It's just acrylic and copper.
But there is a magnet in the ring.
Yes. It only spins if it oscillates. Now, if I have one here which doesn't, nothing.
That's just magnet, yeah.
Just a magnet. There's no oscillation.
And do you have just a copper ring?
I do, but I don't have it hooked up to anything.
Okay.
This is a ceramic one.
Get it started.
It has to oscillate.
Otherwise, the ceramic one will do it?
It will, if I can get it to.
Well, that doesn't make sense why the ceramic one would do it, but the neodymium wouldn't. They're both magnets.
They're both magnets, but it's the oscillation that does it. If they get a wobble, then it grabs it.
Yeah, but does that mean that the neodymium could do it? It just requires a more precise wobble?
Yeah, either one. I've done it with both of these. Either one will do it, but it's that. If it wobbles as it rotates, then it creates the turning. It's just looseness.
And how's that ring? Is that ring glued on?
It is.
Oh, good. Okay.
Yeah.
Let me feel. I'll do it here instead. Okay. Let me do it this way. Tangential?
Oh yeah, that'll slow it down.
you go.
Nice, you got it.
Yeah, I got it. Yeah.
Oh, look at that.
It started kind of.
Once it gets that little oscillation, it carries it.
There it is.
Good job. I haven't tried that yet. That's great.
Doing it, you know, at a 90 degree to it. Man, I like that it's got just enough looseness you can feel the wobble in here when it's actually doing it. But that's interesting that you can get it on the sides as well as on the top.
You get that wobble and it carries it on.
You can almost feel the force in here when it grabs.
It doesn't create enough lift to push that off. Like you can't just rest it on here and have it float above the surface.
There you go.
And once you get that wobble, you're good.
Weird.
Yeah.
I mean, it's eddy currents. I'm sure it's not weird if you understand what's going on. I don't understand it well enough to know what's going on.
What?
Because you'd think you should be able to get it to go. Oh, you know what? Do you have any grease where you could like lower the friction? I mean, it's already Teflon.
Yeah, it's Teflon. I have a dot.
But if there was a way to like lower the friction just a little more, there we go. Yeah, a little machine oil. There you go. Oh yeah.
Much better?
More better.
Teflon and grease.
Just wonder if there's a way that
There, yeah.
it grabs so much easier this way.
It's way reduced the friction.
Crazy.
So that's why that field, that magnet has to be oscillating. It can't just be a straight one like this would be straight or that would be straight. And it's not much. It's maybe like a 1/16 of an inch of oscillation back and forth. But it does grab it and rotate it.
It does. So this makes me wonder about your float height, right? When it's spinning fast enough that they start floating away from it. Mm-hmm. Wonder if you were to put a whole roller on this thing.
I need to try that.
With the directionalized thing, right? Mm-hmm. You could go back and forth and test with those angles, the directions to see, like, does it grab easier? Because I suspect this whole grabbing thing is, you know, that's why you built it.
Yeah, that's the one thing I wanted to test, the bearing effect. And so what I've found is the ones that have that nice big wobble work great. The ones that are straight and forced to stay straight, they're going to do nothing. Which that applies to all the things we've learned. Mm-hmm. Hush.
I'm sure you have played with this for many hours.
Oh yeah.
I would
a lot.
I would play with this for many hours too.
The battery can run for hours and hours. It's hardly any power.
Yeah, as a test device, not just a demonstration, as a test device. Like to be able to test different, like you've already got here. One, so what do we got? South up.
It has 1 point on it, one peak, and it will not oscillate. I made it so it doesn't. It does have an impression on it, but it will not do much of anything. It doesn't spin, which I'm not surprised. The waves don't do this oscillation inside of it.
Oh yeah, I can feel that slow it down.
Yep, it acts like a brake. But yet when it oscillates, it doesn't act like a brake.
So actually, if that's the case, then I want to get it spinning this way and then flip it over.
Let me turn these things on so the lights are on.
Oh yeah.
Got them all off. Yeah, if you orient it at 90 degrees, it'll slow that copper drum down too.
Huh.
It's better.
I was thinking that if I got it spinning one way and then I flip it over, right? So it's already going the way that it seems like the eddy drag is pulling it against, right? And then I flip it over, if I could keep it going longer.
No.
It doesn't matter. Magnets, spinning copper, no matter what, no matter the polarity, no matter what, because there's no polarity to this thing. So this induces the magnetic field eddy current into this, which then fights this no matter what it is.
Unless it oscillates, then they basically work together. They don't have the repulsion exactly. They don't fight each other as much. They just, it acts more like a gear or a bearing.
So by having magnet and copper with copper, it's like the magnet is inducing the eddy current in this guy, and then you got your secondary eddy current going back to this guy. Maybe that's part of the reason why there's like a minimum speed, is because the magnet inducing that eddy current wants to slow this thing down, right? But once that eddy current is induced, it's even stronger because this is slightly closer. The copper is slightly closer to the copper, so that grabs stronger than the magnet.
And in this setup, like they're attracted to each other too until a certain speed where it starts pulling away.
I wonder if you could reverse this and have Teflon copper magnet, right? Because then the magnet would be closer to the copper, and it'll let you see, like, if indeed that's what's happening, right?
So it's like this one is just pure magnet, and then put the copper sleeve under it.
No, like if you had a way of putting a copper sleeve inside a ring.
Oh yeah,
right.
I can do that.
So then it was magnet ring on the outside, copper ring on the inside,
Then Teflon.
and then Teflon. Because for this, where it's just magnet, right, it slows it down, right? This thing gets all slowed down. For this one, it gets all sped up because you have this copper ring on the outside. But that copper ring is closer to this copper ring. So the magnet is farther away.
Oh, because
right?
you got the space.
It's the space. So if you put the magnet on the outside, now the magnet is closer to the spinning copper, which means it'll drag more. So I suspect that would work less well, right?
It might, yeah.
Not so good as the way you have it here, but you know, it's a characterization thing.
And I have the copper, I can do it.
Dude. It looks like you got like a tape in there.
Oh yeah, that was because the Teflon, it was probably made for another magnet. It was a little too thin, so I added it as a spacer. Because it was sliding off the Teflon. The magnet was a little too wide.
Gotcha,
the Teflon was just not wide enough.
250 volts, 17 points. Ooh. Okay, so that's just normal N32. There's no points on that one.
Correct.
This is the same thing as that, except it's got points on it.
Yeah, 17.
Let me try you.
I haven't had as good success with that one either. That's why I've come to think I only need one big peak and a nice gentle oscillation. So not much of anything happens with that.
Man, that thing does not. We need some oil.
Oh. Oil. I never even thought to oil these things at all.
There we go. Oh, much more better. Much more better. What?
Yeah, I'm not surprised. Yeah, if you stick it at 90 degrees to it, you could slow this down. Or maybe a little bit.
I just find it interesting that no matter what you do, it lifts that up. Does that happen everywhere on here? No. Oh, yeah. These things want to get pulled up towards the edges.
The edges, yes.
I wonder if I do it.
Yeah, that field is like, it's shaped like that, circular.
That is an upwards force if this is oriented the right way.
Those are not, let's say radially magnetized, they're just magnetized, through that direction, the normal way.
Now, unfortunately, equal and opposite reactions, right? Upward force on this means downward force on this, but interesting nonetheless. See if I can. There you go.
Yeah, that oscillation is like, oh wow. The oscillation is really important for rotation.
It's fascinating. Yeah, I can feel,
right?
as you get close, you can really feel those eddy currents in there.
Did you see the videos of this from yesterday?
Did I? I don't think I did.
Oh, good. Okay. Let's see. I wanted to show you this. Finding the resonance point on the magnet.
Oh, with the razor blade.
Yes. Okay. Love those brushless motors.
Yeah, I had ideas with that razor blade test.
So eventually I'm going to make a setup like this. It's on a full enclosed enclosure, away from any wind or any kind of anything that might disrupt it. It's just, I can't tell if this is mine or not. Basically, this was just the setup. I found that if I put the magnet here, nothing at all ever happened. But I put on a piece of wood or something.
Yeah, I was curious how much the springiness of the foam affected it.
Yeah, I think that is kind of the effect, and I cannot get it to work with neodymiums. It's only these ceramics I have a lot of success with.
Interesting.
Okay, and you're here. And the frequencies seem to be on octaves. Like if you double the frequency, it vibrates also. Pretty close to that. There, it's tricky to get the thing to work at first, but once you kind of get it working, it doesn't stop working. Okay,
I think you said it was like 19 kilohertz?
Hertz.
19 hertz.
18, yeah, 18. Some, like yesterday I had it going at 18 really well, and then today it was about 18 to 22.
And you're doing sine waves for it, right?
I tried all of them. I tried sine wave, square, and then the ones you can, I don't know the name of all of these. I tried all of them except for flat. All of them worked.
Interesting. I would think square waves would work better, but...
Yeah, I can definitely try square. Let's see if I can see and just bring it up. So I also found is like if I bring the power up, I can bring it way down and still have it working, but it has to be up to a certain level. But then once you get that level, you can just bring it down and it works. So this was just trying something Floyd Sweet talked about. And I want to see if it had any merit at all. And this is the way he would find the resonance points on his magnets. Is it gone? Oh yeah, it is. Okay.
Oh, because you can feel it?
I can feel it. I originally thought it just have nothing, just the magnet right to the coil, which that's what it looked like he was doing, but I never got any kind of results. So I just put a piece of tissue paper and then wood. I don't want to go too much. And at some points I could get this thing to vibrate so much it would fly off. I'm going back down, I need to go up. Am I doing something wrong there? This hurts. I'm going to try it for sine wave. Okay. Back the power off. Yes, that's the one I want. And then there's this. I'm still getting used to this signal generator. I just almost never use it for anything. Okay, there we go. There's one. 18.
Oh, yeah.
That's pretty minuscule to what I've had it before. But 18 seems to be the one I could always hit it at. Oh, there.
All right,
29.
what frequency at?
29. So yesterday I was doing it, I could only get about 18, 19 hertz. Okay, there we go. There's a nice one.
You know, if we...
This is pretty minuscule compared to what I used to have it at.
If we hook that... Oh, no, it won't work. I was going to say, I wonder if we could use the oscilloscope's FFT to find the exact frequency. But I was thinking it was in kilohertz. 19 hertz is pretty low.
That's really low.
Oh, there you go.
There we go.
So once you get it, then you can go down to the tenths of a hertz, and you can dial it in closer.
Yes.
And you did that, and you got it like...
Yeah, I got it down to... I could bring it at...
Oh, it's moving. It's sliding off.
Yeah, see, it was about... That was yesterday. 1820 was the thing. 1820 was the exact number. I was trying with the rectangles at first. Yeah, 1820 was the number yesterday.
So...
There we go. And of course, you bring up the power, you can increase the oscillation.
But like the whole magnet keeps sliding off the
Yeah.
styrofoam. Do you have something other than styrofoam that still works? Something harder?
I tried these tubes and it worked okay, but they would want to slide off that.
Yeah. I was thinking...
I do have this.
Like even a piece of paper.
Oh.
Oh, hey, there you go.
Okay. It's down. So what I found yesterday, it seems like if I went up in the frequency and it barely started to move and then I backed it down, it would oscillate a lot more. But if I just started low and went high, it won't do anything. All right, I'm going to bring back to 18.
There it is.
Okay, I don't want that. There we go. I don't want the power vibrating the magnet. I want the tuning, basically a tuning fork to do.
So this is basically a speaker. This is like the entire components of a speaker.
Exactly, it is. That's looking really. There's 15, 18. So, yeah, I mean, you have your magnetic coil, you have your magnet, and then your fluctuating thing.
Mm-hmm. And so I bet if we look at the documentation for speaker design, there might be something in there, but I wonder if in speaker design, if they've ever thought about what you're trying to do, which is imprint certain stuff onto the magnets, right?
Yeah.
Maybe for like a bass speaker or a tweeter or different size speakers, you use different sized magnets. Maybe somebody out there, maybe Bose figured it out like in the 90s, I don't know. But I have to imagine somebody somewhere at some point said, I wonder if.
General Electric was, apparently according to Floyd and Tom Bearden, General Electric had figured it out. That putting AC signals on the magnets.
Yeah, imprinting the signal into the grains of the magnet rather than just have willy-nilly grains.
Yeah, so that at certain frequencies they respond. Like, I want to get these to be 136 hertz. So that it responds like this at 136 hertz, not just 18.20. Frequency response. So that's what I'm looking to do.
Do me a favor, and now that we got the frequency dialed in, try switching over to a square wave.
Oh, yeah.
So the reason why square waves are good is because you get a lot more harmonics. So sine wave, yeah, you get the harmonics with a sine wave, but with a square wave, the way that these signal generators are built, they can't help it. They have to do every harmonic higher in order to make a square wave.
So when I double this, I found sometimes yesterday and today, I'll try to do it, is when I doubled this, it would work too. Go up to like 36, 34. It would all stop in between, but we would double that frequency, it would start vibrating again. So I'll just try it. Ow. Ow. Okay. Yeah, so it comes to a stop in about 36 to 38 or so. All right, maybe not. And back it down. It's not doing it now. $40. There it is. 29. So it's getting closer to 18, that's why. 24, 23, 20, 19, 18.
There it is, yep.
Yep. So yeah, that's the little gizmo. I want to do a 3D print so you can hold a magnet just like this and then have a pre-made coil underneath it. But I tried it with this coil. I tried it with this coil.
How did it work with those?
They are all responding to 18 hertz.
Oh, it's all the same. It's the magnet. You verified that the magnet is 18 hertz because it's got all these different coils that are all completely different characteristics.
Yep. Different thickness of wire, different winds. That's 950 turns. This is obviously smaller. This I found from a microwave, and they all respond around 18 hertz.
Dude.
So one of the magnets I imprinted, I found I put it right on the imprint point, and it did this at 30 hertz. So it changed it. And now it's floating off.
There it goes.
There we go.
Nice.
The neodymiums are going to be challenging because they don't do anything like this. They're just so strong. I honestly think it's the razor blade because it has a nice, perfectly straight edge on the bottom. So I'm going to have to somehow round this, not somehow, but round the edge a little and let the magnetic field hold it straight instead of just that flat edge holding it straight. That way, when you find that exact 0 point on that magnet, it's the magnetic field holding it perfectly straight up.
Ooh.
So
it's basically floating except for a tiny little, you're taking a razor blade and putting it on an even more razor edge by rounding it.
Yes.
Nice.
Just got to experiment with it and try it. This one has a custom field on it, and so like the center point is like way over here, then way over there.
You see that one?
Let me get the film, I'll show you. I did that about a month and a half ago just to see if I could put anything on it, and it did. Here you are. So this is the cleanest film I got. It's real nice and sharp. That was just, I laid a piece of copper and hit it with the high voltage pulse. Way too much power, by the way. I think it was 1,000 volts.
Oh, interesting. Yeah, you got that waveform on the back there.
Yep. I think that was
That's cool.
1,000 volts that went through that. It should have been about 250. That's why that line is so horrible.
And it's just on that end.
Yep.
That's cool. Oh, you can kind of see it. You can kind of see like a little heart-shaped thing on the top there.
So one of the things we're going to do, you can dramatically lessen the gauge of wire. This is ultra thick, way too thick, but I'm going to make a pattern like this, but more rectangle shape at 21 degrees. Floyd said, so this is kind of following Floyd Sweet's work also, that it had to be slightly angled. So I'm going to do a 21 degree wrapped like this across the surface.
Ah.
So be probably half the thickness of this, so you got a little more ripples.
Nice.
And then the other thing I'm trying, I haven't had any success with, is treating it with high voltage. I let it run through 20,000 volts yesterday for 10 minutes, zero effect. But
So that kind of magnetic field, where would such a guy go in your setup? Or is this just for testing?
That's just for testing. That's Floyd Sweet stuff with its solid, basically a solid state SCG, if you will. Yeah, that other one has no pattern at all, just normal.
Dude, you've been doing some work. We got more, but wait, there's more.
Wait, there's more. So this is really what I'm after, is a pattern like this where it loops around back to here on a ring. You're just looking at the circumference.
All right, let me see this here.
So you have one nice big climbing peak. It goes up and then drops down and then continues back around on the surface of the ring magnet. But then you have all these micro pulses, 136 of them micro pulses throughout the whole circumference.
So 136 magnetic teeth, and then one big magnetic tooth.
Yep. Waves within a wave.
So when you do that rolling on a piece of sheet metal, right, and you got just the one, right, as soon as it catches that, it pulls it forward,
Yep.
right?
Yep.
But what happens when you put a bunch more teeth in combined with that?
I don't know.
like I have to imagine that a bunch of little teeth around that big transition there, it's got to do weird stuff,
Yes.
right? It might amplify that. It might
Cancel it.
It might put a little weird ripple on the way down, right?
I don't know.
I don't know. That's really interesting.
The ceramics, I know in doing this with ceramics will be quite easy because I could just do a jig like this one. This one is 34, so it'd be 4 times the amount of wiring, but not using 14 gauge. I think I'd use 28 gauge is actually it. 136 points, and then probably have to do 2 pulses or 1 big pulse. So you have a ring set up like this. So you'd have a ring wire within wire, so it'd be wound this way. Like this would be wound, but then you have a secondary, which would create this big loop or big spike, but then you have all the secondaries, which would be the tiny little ones. The ceramics, I can easily do it because it's 250 volts at 28 gauge wire. It shouldn't blow it, hopefully. The neodymiums, it'll blow that wire easy.
Yeah.
It won't blow this, but that 28 gauge, it'll just pop it. So
it's a rock and a hard place. You want to be able to get as much current as you can, but you want the teeth to be as fine as they can be.
yes.
Yeah, so how do you balance the smallest possible wire with, I wonder if instead of copper, if you could use something like tungsten.
That was my next thought, actually.
Nice.
Instead of using copper and use something much, much smaller. And the other option is using something with a much finer edge that produces the same field. So either stainless or steel or tungsten, so you can shoot that current through there. And then rotate the magnet for 1 degree, 2 degrees, 3 degrees, 4 degrees.
Yeah, buddy.
Something like that. And then just hit it 4 times in a row.
Yeah, if you only have one and you're putting all that current through the one, it's a lot less wire, a lot less resistance,
Yes.
right? So you're not going to burn that wire up as bad.
And the issue, I've tried this with other setups, it does not work. If you cut the wire, like you join it all at the top, and then have it all connect at the bottom, it doesn't work, no patterns. But if you have one nice big loop, just like this, where it starts, loops, 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 and comes out the other end, beautiful patterns. And it only works if you put the orientation of the magnet in relation to the current. Like that, basically, the negative has to follow the south, and the north has to be up and for the positive.
The whole right-hand rule stuff.
Yes.
Yep.
If you flip it, nothing. I've done up to 8,000 volts.
You
no patterns.
cannot beat that rule, no matter how many volts.
Beat it.
Nice.
You cannot beat it. Yeah. I tried with those. 8,000 volts, not a single pattern. That's wrong. You flip it around 250 volts, easy peasy. Oh yeah, so we'll have to try this tonight when it gets dark, but I hooked this up to the
Oh, the Tesla coil.
Oh, it's so cool. So you can play music through it with your phone.
Yeah, buddy.
They're so cool. And you could just hold it in your hand. It tingles, but it doesn't sting. It's really cool. So I hooked that up to the SEG while I was running, and sparks were plentiful.
Wonderful. I'd be interested in seeing what happens with the arc if you bring it close to that other speaker magnet combo there with the 19 hertz, right? And just see if with a solid tone going through this, that is probably some multiple of 18 hertz, right? If you could bring this close and you could see how those two interact, right? You might get even, yes.
All right. So you can also connect this with one of these wires. It barely tickles, if you want to use, I don't know. It barely tickles compared to the other high voltage I got here, which that was painful. I think everything is still plugged in.
Balancing on its razor's edge. There you go. About ballpark. And this guy you had at
18.20 is like optimum. You may have to go up and then bring it back down. And is that still, oh yeah, that's about right there. Everything's still plugged in right.
Okay. And channel 1, oh, channel 1, no, maybe channel 2. And then the voltage, the amplitude there. Oh, no, channel 1. All the power. There it is.
There it is.
All right, and then this guy's plugged in.
I think that's power and this is frequency. What?
We're gonna have to wait until it gets dark to really see it.
Yeah. This one's fun because it doesn't hurt. You can smell the ozone though.
So what I really want to do is get this set up so it's going at the tip. There we go. Oh, it's arcing down to the coil. That's not good. Don't want to do that. That'll burn out the signal generator.